Hi everyone, in this video I want to explain why computers use ones and zero, the so-called binary system, to work instead of the decimal system, which is the system that we human beings use. So the first thing we need to understand is what is a numeral system, because binary and decimal are numeral systems. Numeral systems are structure we use to represent numbers. For example, the most basic system you could have is the unary system, also called tally marks. In this system, we only have one symbol, which is this one usually, and every time we want to represent a number, we have to repeat this symbol up to the number we want to represent. So for example, that would be 1, 2, 3, 4, and so on. But as you can see, this system is not really efficient, because if I want to write down, for example, 1 billion, I would have to repeat this symbol 1 billion times. And when I want to read this number, I would have to count up to 1 billion before knowing that the number represented is 1 billion. On the other hand, as we said, we human beings use the decimal system or the positional decimal system. Positional because every symbol has a different meaning depending on the position we write it down, and decimal because we have 10 different symbols from 0 to 9. So for example, if I want to represent the number 542, I can write it like this, and when I read it, I know that this position are 100, so I know that this is 500 plus this are tens, so it will be 40 plus this are ones, 2. So just with these 3 digits, I know that this number represents 542. As you may know, computers use electrical signal to represent information. So how would it be if we wanted to implement the decimal system in an electrical system? Let's say we have a box for each digit of the number we want to represent, and a way to put an electrical signal in each box, and a way to read the electrical signal we have in each box. So as we said, in the decimal system, we have 10 different symbols. So we need a way to be able to put 10 different electrical signals here in each box. So that would be having an electrical signal for level 0, 1 for level 1, 2, and so on up to level 9. So for example, in our case, let's leave this. If you want to represent the number 542, we put here the electrical signal 2, that would go here, and here the signal 4, that would go here, and here the signal 5. That will go here. Unfortunately, this system would work only in an ideal scenario, because in a real world scenario, we have interferences. For example, in this number that we are trying to represent, we have here the digit 2 that is here because we put the signal at level 2 here. But let's say there is an interference. So this number would become 3, and we would have a 3 here. And in the real world, we have interferences everywhere. Our bodies and interferences, other electrical devices have interferences. The world itself has interferences. So it is really complicated to have a system where we can reliably generate an electrical signal at a specific level that would not be changed by interferences. If we know, for example, what's the maximum interference you can have in a real-world scenario, in an everyday use case, we could higher the distance between one electrical signal and the other electrical signal. So, for example, instead of having level 0, 1, 2, up to 9, we could have level 0, 2, 4, 6. So, if we have an interference of maximum 1 level, this system would be still reliable. As you can see, it would be much easier if we had only 2 levels we needed to represent. That's why we use the binary system. We will have the signal 0 or false and the signal 1 or true. In most systems, the level 0 is represented by a signal of 0 volts, and the level 1 is represented by a signal of 5 volts. So for example, if we have a 0 volt signal which represents level 0, and we have an interference that make it go up to, let's say, 2 volts, it would still be interpreted as level 0. So this is one of the main reasons computers use binary, because it's reliable and it's fairly easy to implement. I hope you enjoyed this video. See you in the next one. Bye.